Hey, KCS at Home Summer Edition. It's Andrew Turner from Central High School. We are continuing linear functions going into part 2. So we had just talked a little bit about graphing in slope-intercept form. Slope-intercept form is y equals mx plus b. We talked about that component m, the slope formula, y2 minus y1 over x2 minus x1. And we also talked a little bit about standard form, and standard form is what both of these are in, meaning you need to change them where the output variable y is alone, or you solve for y in order to get that form that you are looking for. And so this one says we're going to get two equations, and it says change the equations from standard form and we graph them to find where they intersect. So let's kind of determine how they got these lines graphed. So the first thing I want to look at, 2x equals 10 minus 3y. Really wanting to get y by itself. This output variable y I want completely alone. And so let's start by subtracting 10 from one side to the other. Now this step, like I said in the last video, is really just moving that constant of 10 to the left side. So we're subtracting 10. But because 2x is not a like term, we don't want to say that's negative 8. Or we don't want to try to put those together in any way, just to move 10 to the other side. And negative 3, we want to divide negative 3 to the other side. And when we do that, we're going to end up getting negative 2/3 x, negative over negative, positive 10/3, and then there I have y by itself. And if you don't like y on the right, because it's an equation, you can use the symmetric property and you can put it on the left. 2 equals y or y equals 2, they both mean the same thing. And so when we look at that 10/3, that y-intercept, going up to 10/3, just a little fraction decimal there, and it looks like they've kind of gone down 2 and over 3, and this is very much an estimate just to kind of show you, but right there is the next point. And if you can find a really good point, for example, that looks like a fairly good point, it may be easier to see that down 2 and over 3 as it hits the coordinate plane in really nice spots. And so let's take this other equation. It looks like it's 3x plus 2y equals 5 here. And same idea, I want to get y by itself in order to change the form of the equation so that it is in what we call slope-intercept form. So again, I want to move that 3x from the left side to the right using that subtraction equality property, subtraction property of equality. And then let's use division as a property to get y completely alone. And now we see that slope is negative 3/2 x and 5 over 2, just to kind of help you out there, that's 2.5. We could leave it, I would prefer to leave it 5 over 2, but just to really show you, that is right here at 2.5. And again, that slope, we're going to see it going down 3 over 2. I mean, just a really quick estimate just to kind of show you how that line has a slope of negative 3 over 2. Well, very important that when you're solving by graphing, when you're solving a system of equations, that you can find that point of intersection, and for this one, it's crossing at negative 1, 4. So we're going to talk a little bit about how there's 3 possibilities of a system. They can cross once, they don't have to cross, they could be parallel, or they could technically be the same line. And so we really want to look out for that as we see it. And so the next part we're going to talk about is solving a system using what's called linear combination, or think of it as elimination in some classes. And so we're really trying to look for a way that when you add these two equations together, you get the variables to cancel either the x or the y. And so we really have to think about what would cancel. Positive 3x and minus 3x. That would make 0. Or negative 4y and positive 4y. If you add those together, that makes 0. So we're kind of looking for the same value, but they need to be opposite in sign. And you can use multiplication to change an equation however you want. For example, I'm really seeing, 7 and 4. I really can't get 7 to become 4 or 4 to become 7 without using fractions or decimals. And really you can do that. It just makes it a little harder. But if I see that this is a positive 2 and here is a positive 1, I really could change that to be a -2 if I think about what I would need to multiply by to change that whole equation so that there is a -2 in that position. And so I want to multiply this whole equation by -2. -2 times 4, -8. -2 times 1y, -8y. -2 times 15, -30. And so what happens is when you go to combine these two equations now, you can just rewrite that other equation. It doesn't change at all. But now when we add these together, your variables are canceling. 7x plus -8x, that's -1x. 24 plus -30 is -6. And then when we divide that -1 over, we're figuring out that x has to be the value of 6. Well, we can now replace x with 6 using one of the equations, and we can solve to find the other value by combining like terms and using those properties to get our variable solved for. So these two lines are going to cross at the point 6, -9. You can replace x with 6, replace y with -9 in either of those equations, and it's going to work perfectly. For example, 4 times 6, that'd be 24. You are adding a -9 to that, and that is in fact 15. And so we are looking to solve for exactly where they cross. So let's try another example where we're kind of solving for y, trying to figure out where they're going to end up crossing. So let's talk about that first one. We want to get y by itself. So let's add 16 from one side to the other. 8x plus 16 equals -8y. And then using that division property of equality, let's divide -8 over to the other side. And it looks like one of my equations should be -1x minus 2. So let's stop and just graph this for just a moment. The y-intercept value, this is that -2, or that mx plus b value. That b represents that y-intercept. So let's start at -2, and then the slope, it's that -1 value in front of x. So let's go down 1 and over 1. And I can even go backwards and go up and left if I want. And this is creating a line that has a -1 slope. Let me get a little further down on the graph so that I can have a few more points. Because if our goal is to find where these two lines cross, I may need several points around the origin to determine their crossing point. So let's take that second equation, 12x minus 4y equals 8, and let's solve for y. Really consistent steps here. Let's move our x to the other side. It's adding to -4y, so let's use the subtraction property of equality there. And we don't actually combine these. 12 and 8 aren't like terms because x has that, or 12 has that x on it. But let's finish out by dividing the -4 to the other side, and we get positive 3x minus 2. So it looks like they're going to start at that y-intercept of -2, but they just have different rates of change. One goes up 3 over 1, while the other one is more going down 1 over 1. And so we want to really locate that point where they cross, and the x is 0, and the y is -2. That represents the solution to that system of equations. Now, they don't always have to cross exactly at one point. Really, you're looking for, different slopes. Are the slopes going to be different, which is going to force their angles to basically run into each other or intersect eventually in the coordinate plane? But what if their slopes were the same? What if they were what we call parallel? And parallel happens whenever you have the same slope. And in this case, you have two -5/4 or two +3s for your slope. So that means you're never going to have a point of intersection, which means there's no solution. Or maybe they slightly look different in their presentation, but once you solve for y, divide everything over y by itself, you may find out that you're talking about the same line, and so every point is in common, and you go from in the middle case, no solution, and now you're talking about infinitely many solutions. Right there. Every point that they have in common is considered a solution. So let's take a look at a word problem. Marcus opens a new bank account. He deposits $25 that he won from a robotics competition. He plans on depositing $10 a week from tutoring. So see, this is what I'm picking up on immediately, is that this value happens more than once. This value is a rate of change. This is your slope. But the deposit, this is kind of your initial value. That's more of like your y-intercept. That's like the b value in our equation, versus 10 being like the m or the slope in our equation. And so he's wanting to save some money and open an account, and so is Philip. So they're a friend of his, maybe. He already saved 40, so there's his y-intercept or his initial account. But he's depositing also $10 a week from his allowance. So we have, the first situation where he says, hey, I'm making $10 a week, and I already had 25 to begin with. That can be Marcus's equation. Well, when we look at Philip's equation has something that's similar in it. They both are depositing $10 a week, maybe for different reasons. One is from allowance, one is from tutoring, but they are making the same amount every week. However, they are starting at different places. Philip started with 40, Marcus started with 25. So over time, they are going to stay the same distance from each other. For example, I could make a quick table. So, Marcus had a different amount of money starting. He said, okay, initially I had 25, and a week later I add 10 to that to get 35. Another week I'll add 10 to that to get 45. But for Philip, he's got a similar situation for his table. He'll say, well, initially I had 40, and then a week later I added 10 to get 50. I added another 10 to get 60. And so if you really think about this, they're never really going to cross each other. In one case, you're starting at $25, and you're adding 10 over 1. Adding 10 over 1. Okay? But then when you talk about Philip, it's similar. You're starting at 40, and then you're going up 10 over 1, up 10 over 1, up 10 over 1. And so these lines end up being parallel. They're never going to actually cross each other. Someone's going to have to start making more than $10 in a week in order for that angle of that line, that slope or rate of change, to make them intersect eventually in a different place. Okay? So that is going to end us for the linear functions video. Please email me at andrewturner@knoxschools.org if you have any questions about the practice over this summer, and good luck.